The standard offer. Oh, sorry.
Back to the batteries.
Yeah.
What are they doing in Wolf Island? They can't.
That's right. They don't have batteries, right? So they pump it right back to the grid. They bypass all this stuff. But they have to make that power into a usable
AC.
Yeah, usable AC, and then they transport it in really high voltage over in behind Home Depot. There's a big substation there. That's where it goes. And then from there it goes back into Kingston.
It goes all the way up to Home Depot?
Yeah. So there was a big underwater cable that was laid, and it comes out right in front of DuPont, goes up Days Road, and then up Gardner's. Yeah. Big money. So the standard offer contract, so this is net metering. Watch it. Ready? That's standard offer contract. So basically, you have a second meter, and instead of your power coming out here and going into your panel, you go through a meter first, and it's up for grabs at the grid. And what generally happens is you're going to pull that back into your home. But you can get that 11 cents, or if it's solar, 42 cents first. And then it goes back into your home and you consume it. So under the standard offer contract, every month you'll get a check, which is nice from the government, and you'll get a bill. And you do the difference in your pocket. But with wind, like I said, it's about 11 cents once it gets to your plug. They're only giving you 11 cents. So it doesn't make a lot of sense, sorry for that. But the reason for it is because it costs anywhere between $1,000 and $1,300 to put in another meter. So you have to absorb those costs for really no benefit. The other thing...
So price changes, okay?
Yes.
Okay, maybe more advantageous.
Then you can absorb that $1,300 or whatever that price is. And that's not your installer's price, that's Hydro One or utilities. They charge that fee to put in a separate meter. With net metering, which is most of our clients, the reason why we go to net metering is because they're not really going to meet 100% of their loads on a monthly basis. So it's not advantageous to meter how much extra is going to go out to the grid. If they were in that situation where they had a big turbine and little loads, then it would. So that's another point to think about.
Can you talk about certain standards that you need to meet?
Yes.
If you're connecting to the grid?
Yes.
Like with your local utility?
Yes. So which standards do you need to meet?
Yeah.
Yeah. Well, they're basically, one of the biggest things is the kind of AC that your inverter puts out. Okay, like you can get an inverter from Canadian Tire for $5 and plug it into your car and plug your phone into it or whatever. That makes a very dirty AC signal. Alternating current should be just like a beautiful curve. It's called a sinusoidal curve. The ones that come out of that are kind of like a square. And they don't meet those. It's really dirty. And what that can do is destroy sensitive electronics. So these make that smooth curve. And they, like I said, this is at such a smooth curve that you won't be able to distinguish it from any other power that's on the grid. And so that's one of the biggest things that they look for. There's other things like basically safety concerns, so that if a linesman is up working on the line, they can lock out your generator so that they're not going to get electrocuted. Things like that, which your installers will help you through.
And if there's like a problem from the utility grid, from the grid,
yeah,
would it affect your system? Would it affect your system?
No, there's no way that could affect your system. You mean could it like go back through?
Like, could you like have like something like a cut off in your system if there's a problem from the grid?
Well, it depends. If they cut off, if the grid goes down, for instance, some turbines are looking for that signal, so that as that AC is coming in, it sees it and it matches it to go on that same wave. And so if the grid is down, it shuts down. So that sort of situation can happen, but that depends on the turbine. If you have a turbine like this, then what happens if the grid goes down is you have your batteries, and the power goes out through here and into here, and it doesn't matter.
So if after you get your windmill, inverter, and stuff like that, it costs $1,000 to $1,300 to get it all hooked up to the.
Well, that's grid. Yeah. Well, that's no, not necessarily. What I meant by that is that's the price that Hydro One will charge to come out and put the meter in the new spot where the new meter should be. That's called a meter base. So for our clients, we wire that up, and there's the box there, and it's empty, and they come out and they put that in, and that's that fee. So basically, to get that new meter in and to get it working, and that's completely outside of our hands.
So what
So
is the cost after the inverter, stuff like that?
Yeah.
To get hooked into the grid?
Well, there's not a whole lot, to be honest. It's basically, this is electrician work from here on, and so that amount in the project scope is fairly small. If you're talking about like a $16,000 project or something like that, it's not more than $1,500 or something of that for the electrician to do all the permits and do all that, the other side of things. Time is coming short, I guess. Ben, I think.
I was going to ask, what happens if there is a surge of winds and you're on the net metering? Does your turbine just shut down on that?
Yeah, so every turbine has a way to stop itself if there's high winds. There's mechanical means. So there's ones where the blades, if it's a fan, they'll tilt back out of the wind. So basically they don't spin as well. And there's all kinds of governing mechanisms to slow it down.
But what if you're producing? Too much power? If maybe the winds isn't necessarily blowing really fast, but you're just not your home just isn't requiring that much.
Oh yeah, in that case, if you're producing more than you need, it goes back to the grid. And because it's all regulated,
Under net metering?
yeah, it goes back. And so under net metering,
But you don't get the 11 cents.
right. So say in a month you produce more than you need in that month, and say it's 500 kilowatt hours more than you need, you'll get a credit for 500 kilowatt hours from Hydro One or utility to use, and that expires in a year if you don't use it. But that's how that works. And I think we're getting low on time, but
Do the wind turbines have any standards that they have to meet certification?
Oh, yeah. for sure. Again, it's the UL rating that you want to see, and it's going to have the C in front of it to be Canadian.
Do they all have it? Or?
Yeah, anything that's you should make sure. But anything that anything that you would have installed, make sure it has that on it. The UL rating, a lot of devices have CSA. Maybe not the turbines particularly, but other parts of all these integration pieces. You need to make sure that definitely the one that you want to look for is UL with a C in front of it.
Yeah, well, what I was getting at was the power output and the figures that provide to you.
Yeah.
They sort of, as a result, they actually qualify.
Oh, I see what you're saying. Like, are they calibrated at some independent lab or something? Yeah, sure. Again, the National Renewable Energy Lab in the States does a lot of work for this. They have a whole bunch of great little test stations where they put these turbines up and let them run, and they not only get power outputs, but they look at noise production, reliability tests, and things like that. So that's the independent source. There are other ones as well. But